In this video, we are going to be discussing section D and E from the sample question paper 2024-2025. First of all, I would like to apologize for not posting this video sooner. It did take me quite some time to solve all of these questions on my own. I usually like to solve each and every question on my own to see how easy/difficult it is, and it was difficult. So good job. You guys are doing a phenomenal job of preparing for your boards, preparing for the countless number of exams that you're probably taking. I just wanted to remind you that you've been doing a great job. Okay, so first of all, we're going to be talking section D and E. Before that, I will also upload a video which compiles all the sections, so you have the whole sample question paper in one spot, so you can feel free to check that out as well. So section D, so usually you have a case-based questions in this section, and it carries 4 marks of 2 + 1 + 1 each. We need to read the paragraph carefully. This is the 6th time I'm trying to start recording this video, and I realized that reading through the whole thing is not you can read through the whole thing. You should definitely read through the whole thing. But I'm going to point out some very important points from this given paragraph. So basically, this paragraph talks about how you can't predict a reaction from the overall stoichiometry of that particular reaction. It's a lot more complex than we think it is. Okay, so they took an example of specifically reaction of hydrogen gas with bromine to give us hydrogen bromide. And according to them, the concentration, the rate of the reaction was found to be proportional to the concentration of H2 and its square root of concentration of Br2. So this is the important points that and basically the currently accepted mechanism is more complicated, because you would think, if you think about it, the bromine molecule has to dissociate and to form atoms, and then it undergoes a chemical reaction to form hydrogen bromide. So it's a little more complicated. That's what they're basically saying. So from here, we obviously know that this is from the chapter Chemical Kinetics. So first question over here is predict the expression for the rate of the reaction and the order of the following. So we need to basically calculate or write the expression of the rate of the reaction. Now in your textbooks, right, I decided I'm just going to bring out the whole textbook to you guys for this video, because the questions are very specific, and also I just felt like it's easier to have it here. Okay, so from the rate equation, rate is equal to K into A to the power X into P to the power concentration of B to the power Y. From here, they've already told us that the rate is proportional to the concentration of H2 and square root of concentration of Br2. And because of that, you will have, the rate would be equal to K into concentration of H2 into concentration of Br2 to the power 1/2, because it is proportional to square root of concentration of Br2, and so we have to incorporate that, so it is half. The next question we have over here is the order of the reaction. So the order of the reaction is essentially going to be X plus Y. That's all it is, right? I wonder if yes. So according to this is the rate of the reaction equation, and the order of the equation is going to be X plus Y equals to N. So over here you will have X, which is 1 plus 1/2, which is equal to 3/2. That is the value of N, right? That's the order of the reaction. The third question is the units of the rate of the above reaction. So essentially what we are going to do is we are going to use this particular equation. Okay, according to this, you have concentration by time. So into 1 divided by concentration to the power N. Okay, so you're going to have moles. So the units are going to be moles per liter per second, because concentration moles per liter per second is for by time, into 1 divided by moles per liter, because concentration, right? And this to the power 3/2. When you simplify all of this, that's where you get, this. That's how they've gotten this equation, and that's how you get the value of or the units, which is mole to the power minus 1 by 2, liters to the power 1 by 2, and per second. Okay, so essentially we just use this equation to substitute and calculate the unit of K. Okay, so obviously this particular question was related to the molecularity, order, and the rate of the reaction. Okay, I hope that made sense. Now the second question, how will the rate of the reaction be affected if the concentration of Br2 is tripled? Now essentially what we are trying to do is we are seeing what will happen if we triple the concentration. I wonder if they've calculated this. So what they've done over here is basically rate dash is going to be 3 times the concentration of Br2. Now basically what we come to is rate dash is a root over 3 rate, which basically means that the rate is going to be root over 3, square root of 3 times of the rate of the original reaction. So since the rate is proportional to the concentration of H2, when concentration of the bromine is triple, the rate of the reaction is also, or Br2, the concentration is also going to increase, or the rate is also going to go up. Okay, now how will or what change is the concentration of H2 so first of all over here, if you notice, rate of the reaction is directly proportional to hydrogen concentration. Because of that, the rate of the reaction will also increase or will also be tripled when the concentration of hydrogen is tripled. Okay, so essentially these two are quite related to each other. We're talking about how the concentration, when it's tripled, how will it affect the rate of the reaction. For Br2, it's a root over 3 because of the square root that exists for bromine concentration, whereas this is a directly proportional, so it'll just increase by 3 times. Okay, the next question. Suppose the reaction between A and B was experimentally found to be first order with respect to both A and B. So the rate of the reaction or reaction equation is going to be rate equals to K of concentration of A into concentration of B. Which of these two mechanisms is consistent with the experimental finding? Why? Now we know from, I know that this is something you obviously know, that the rate of the reaction depends upon the slow step. So whichever slow step has both A and B, that slow step is what is going to be the mechanism. In this case, A gives rise to C plus D is a slow step. However, we know that it is the rate of the reaction is dependent on both A and B. So in this case, the rate would have just been dependent on A. So mechanism 1 is going to be wrong. On the other hand, mechanism 2 has both A and B in it, and we know that the rate of the reaction is dependent on the slow step. And so, or it's also called as the rate determining step. The rate determining step is always the slow step. So mechanism 2 is going to be the right answer. And this is also under the molecularity of the reaction, where they talk about the rate determining step. Okay, now question number 30. Now here, they've talked about amines. So amines is obviously from the chapter amines. Amines are basic in nature. So they've given us the pKb value is the measure of basic strength of an amine. Lower the value of pKb, more basic is the amine. The effect of substituent of basic strength is determined using titration. Substituent X is replaced in piperidine and propylamine. So basically they've given us an experimental data which gives us basically the substituent, the electronegativity of that substituent, substituted piperidine pKa, substituted propylamine pKa. So they've given us the values of pKa. Okay, now study the above data and we need to answer the following questions. So plot a graph between electronegativity of the substituent versus pKb value of the corresponding substituted propylamine. So essentially we need to plot a graph between electronegativity of X and the pKb. Okay, now we also know that pKa plus pKb is 14. So the thing is, over here, the moment I read this question, I was like, oh, we've not been given enough information. No, it's all right here. So remember to calmly read the question. Unlike me who jumps to conclusions. It's okay. So basically what you'll be doing is you'll be calculating the value of pKa by subtracting 14 from this value. Okay, because pKb is 14 minus pKa. So we're just going to subtract 14 minus 10.67, 10.08, 9.45, 9.28, and we are going to get the corresponding pKb values. Okay, because they themselves have given us this. Okay, so based on that, we are going to get a graph like this. Essentially, what we've just done is plotted a graph between the electronegativities and the value of pKb. That's it. Okay, now, is there a relation between electronegativity and the basic strength? We've noticed that when you have a highly when pKb increases with the increase in electronegativity. So basic strength decreases when the electronegativity increases. Now logically this also makes sense, because that will mean that these electronegative ones will decrease the basic strength of our molecule. Okay, so that's it. So more electronegative substituent weakens the basic nature, because when it pulls more electrons towards it, it will make it difficult for the compound to act as a base. Okay, so this is a very straightforward question. All you have to do is calculate the value of pKb and plot a graph between this and this. I believe in you. You got this. The electronegativity of substituent is 3.7. What is the expected pKa value of compound so and so? So we need to essentially calculate the pKa value. Actually, we don't. They've given us these options and we need to figure out which one's the right answer. Now, the electronegativity of this substituent is also given to us. Now, basically, we spoke about one very important thing. When the electronegativity increases, the pKa value is also going to decrease, right? So this obviously means that the value of this particular thing should be less than 9.28. Because of that, the only option that fits that is 9.1. Okay, so this is just a general trend relationship that we are observing, and from there we are able to figure out the value is 9.1. The other options are obviously about 9.28. The second question, the pKa value of the substituted piperidine formed with substituent X is found to be 8.28. What is the expected electronegativity of X? Now, we are talking about piperidine. Okay, pKa value is going to be 8.28. Now, 8.28 as in, it's in between 8.36 and 7.94. That's the value of pKa. It's in between these two, and it's actually closer to 8.36. Okay, so this implies that the answer we are supposed to mark off is going to be closer to 3.44 and in between 3.44 and 3.6. So out of all of these options, 3.4, 3.8 and 3.1, none of these are within the criteria that we wanted, and because of that because it has to be above 3.44. 3.4 is obviously below, so the answer is going to be 3.5. Okay, I hope that makes it took me a second to figure these relationships out, but it made sense in the end. What is the most suitable pKa value of the substituted propylamine formed with the substituent X with electronegativity 3.0? So we're talking about propylamine with electronegativity with a substituent of electronegativity 3.0. Again, it's the same thing over here. You have a relationship between the electronegativity and pKa value. So the 3.0 is in between 2.55 and 3.12, again closer to 3.12, right? So the value has to be in between 10.6. The pKa value has to be between 10.67 and 10.08. So amongst the options that are given, 10.67, 10.08, these are our upper and lower limits based on this question. So the obvious answer is 10.15. Okay, so all of these are just looking at the information given to you and you're just figuring it out. You got this. The next question is for visually challenged learners. How does the electronegativity of the substituent affect the pKb value? So essentially what they're doing over here is they're asking you to basically tabulate the graph and just give them the values of pKb. So that's what is given in this solution as well. So you just have to write the value of pKb or calculate the value of pKb. So that's instead of the graph. And then you're just going to explain that when you have an increase in electronegativity, basic strength will also decrease because of the increase in electronegativity of the substituent. And then you have question B, C, and this question. All of this are the same for both cases. You're just figuring out the trend and trying to mark off which option suits the best. Okay, now that's it for section D. Section E. The following questions are long answer type. They carry 5 marks each. All questions have an internal choice. So I will bring out my whiteboard again. Hang on, let me actually. Okay, so, oh, I don't want that. Oh, I don't want that either. Okay, this is fine. So, a purple color compound A, which is a strong oxidizing agent and is used for bleaching of wool, cotton, silk, and other textile fibers, was added to each of these 3 test tubes along with H2SO4. It was followed by heating. So, this obviously is from the chapter. I mean, it is a purple compound A, so it's obviously going, and it talks about reactions with PBS, oxalic acid, and potassium iodide. So this is obviously from the chapter. And he guesses D and F block elements. We're talking specifically about potassium permanganate, right? So because that's the purple compound, and under potassium permanganate you have the reactions in acidic solutions. So we need to figure out which of the above test tubes will have violet vapors will be formed. So when potassium permanganate reacts with potassium iodide, it leads to the formation of iodine vapors, which is violet in color. So this implies that this is option, like it's test tube C. The second question, the bubbles of gas evolved will extinguish a burning matchstick. So this is burning matchstick getting extinguished is a characteristic example of the carbon dioxide gas. So oxalic acid is the reaction with which it forms carbon dioxide, and they are asking us to write the chemical reaction, so you just need to mention these, and that's what is given in your solutions as well, but these are actually given in your textbooks too. Now the next question, a metal ion Mn plus of the first transition series having D5 configuration combines with 3 didentate ligands. Assuming delta 0 is less than P, we need to draw the crystal field level diagram. So basically we know that the free metal atom, and then it has 5 its ion has 5 electrons in the D5 configuration. So you have 5 electrons. Now it splits up into Eg and T2G. Basically, based on the strength of your ligand, it determines if if the electrons will get paired up in the lower level, or it will move on to this Eg level. So here they've told us that delta is less than P. So this implies that the 4th electron will enter one of the Eg orbitals. So that's the reason it is entering this orbital, and so it'll enter this and then this, because of this the fact that the delta is less than P. Now this is based on obviously the chapter coordination compounds, and it specifically is dealing with the concept of crystal field theory. We need to, what is the hybridization of Mn plus in this complex and why? Now we obviously have 3 didentate ligands, so that implies there are 6 bonds. So or coordination number is 6. I'm so sorry, I've been doing a lot of organic chemistry. So the coordination number is going to be 6. So you have 2 options. You have sp3d2 or d2sp3 for the octahedral complex, right? So basically the strength of the ligand determines if this is going to be d2sp3 or sp3d2. So d2sp3, as in what will happen is it will force it to pair up. Okay, so if the ligand is a strong field ligand, what it will do is it will force the things to pair up, and then it will lead to the formation of D2sp3. However, ours is a weak field ligand, and because of that, it will just chill and it will just let it bond on the sp3d2 hybridization. So it'll lead to the sp3d2 hybridization, and so the answer to this question is going to be sp3d2 because of the fact that it's a weak field ligand. Okay. Now the next question, name the type of isomerism. So under the concept of isomerism for coordination compounds, you have that the optical isomerism is common for octahedral complexes involving didentate ligands. So because of that, this will show optical isomerism. Okay, now the next question. So this question was basically related to the valence bond theory and crystal field theory of coordination compounds. The next question, that's your option, is also related to these concepts. So you have, based on valence bond theory, we need to identify A, B, C, D, E, and F. So first question over here you have is we need to find the central metal ion. So the central metal ion in this case, what is it going to be? Now we know, I'm going to zoom that in a little bit. Hang on. Oopsie. Okay. So you have COF4 2 minus. That's the okay, so you have, okay, why is this? Okay, so COF, I'm going to 4 2 minus. So now we need the central metal ion. We need to calculate the oxidation number. So X plus 4 into minus 1 because that's the charge by fluorine ligand, and this is equal to minus 2. So we just have to solve for X. So that's going to give us X equals to 2 because 4, it goes to this side and then it becomes plus, and then you are left with X is equal to 2. So the ion is going to be CO2 plus. Okay, that's the first one. The next question over here you have is the number of unpaired electrons. So the number of unpaired electrons for this, we've been given that it is 3d7, right? So 3d7 as in 3d7. So 1, actually I should just, so 3d7, 1 2 3 4 5, then 6 7. So you have how many unpaired electrons? If you said 3, you are correct. So you have 3 unpaired electrons. So the answer to B is going to be 3, and that's what is given over here as well. Let me scroll that down. So we have that as well. So the next question is related to this particular complex. So we need to figure out the hybridization of the metal ion. Over here you have C2O4 twice, which is C2O4 is as such a bidentate ligand. So it's going to form 2 bonds. I mean 2 bonds with the central metal atom. So you have the total of 6, right? So that's going to be an octahedral complex, which is also given over here, I guess. So here your this is 3d3. So because you already have 3d3, it's just going to basically use the D2 sp3 configuration because it already has these 2 spots free. So it's going to undergo D2 sp3 hybridization. No, I guess. Oh my goodness. Just gonna say D2 sp3. Okay. The next question is related to the magnetic behavior. Now, since you have these unpaired electrons, it's going to be paramagnetic. Okay. Now, the last question is related to a nickel complex. Now, we need to figure out the hybridization. Over here, it has 4 ligands attached to it, and so from this, we know that it can either be tetrahedral or it can be square planar. Tetrahedral if it's an sp3 hybridization, dsp2, and then it's a square planar. Now from this we can see that 3d3 and 4s, or sorry, 3d8 4s2, that's the configuration of central metal ion. So it's 3d8 4s2. Okay, so this obviously means that it's not going, it's basically the cobalt is going to push all of your electrons, these two electrons, into 3d shell. So it's going to be 3d10 for your metal atom, and it's basically going to be filled up, and then it'll have the sp3 available for the metal ligand bonds and so coordinate bonds, and so the hybridization is going to be sp3, which is tetrahedral. Okay, so the hybridization is sp3 and the geometry is going to be tetrahedral. I hope that made sense. All right. The next question. Write the ionic equations for the reactions of acidified potassium dichromate with H2S and FeSO4. So basically, this is the reaction given to you in your textbooks. But remember, it's an ionic reaction, so you have to make sure it's balanced. So they've only talked about the reaction with iron. You will have to balance it and get this to write the reaction with H2S. Okay, the next question, question number 32. Give the reactions for the following. I love organic chemistry, I'm not gonna lie. The reaction of ethanol with acetyl chloride is carried out in the presence of pyridine. So this is from the chapter alcohols, phenols, and ethers. So this is one of the reactions of ethanol with acetyl chloride, and it's basically acidification reaction. So essentially what's happening is we need some amount of pyridine because because it's right here. It's carried out in the presence of pyridine, so it is neutralizing the HCl which is formed during the reaction. So because it is neutralizing the HCl, the reaction will keep moving in the forward direction. To make sure that the equilibrium is constantly on the forward direction, we need the addition of pyridine, and that is what is given here as well. Next question, cresols are less acidic than phenols. So cresols are essentially compounds where phenols are substituted with a methyl group. It could be ortho, meta, or para. But basically, the acidity of phenols depends upon the ability of the formation of phenoxide ion. Now, when you have an alkyl group which is electron releasing in nature, what happens is the phenoxide ion will basically not, this will in turn not favor the formation of the phenoxide ion, and because of this, cresols are less acidic than phenol. Okay, and this is under the concept of acidity of phenols. The next question is, Williamson's process is used for the preparation of ethers to form ethers from alkyl halides. Identify the alkyl bromide and sodium alkoxide used for the preparation of 2-ethoxy 3-methyl pentane. Now, the Williamson synthesis is the preparation of ethers, and this is the reaction. Basically, it will prefer the primary alkyl halide. Now, what we're going to do is we're going to write the structure of the product that is formed. So first start with writing the structure of the product form. For us to do that, we know that the bigger chain is going to be consisting of 5 carbon molecules. So this, you have 5, and in the second position you have the OCH3 group, because CH2CH3, and then you have the methyl group in the third position. Now we're just going to fill in the hydrogen atoms. So 1, 2, 3, and this will be 4, and then 1, 2, 3, 4, H2. So this is the ether that is formed. So since it prefers to form use primary alkyl halides, so this is going to be CH2 CH3 Br. Okay, so this is going to be the primary alkyl halide. The next one is just going to be this with ONA. So CH3 CH CH CH3 CH2 CH3. 1 2 3 4 5, and then you have O Na. So these two are going to react to form the ether. Now I did notice that this particular thing given is slightly different than what we have over here. If you have a valid reason as to why this is the right answer, definitely let me know. But basically what I had just done was you have the R-ONA, and I know that the R- group is this whole group, and because of that I just said this. So if you have a valid reason, definitely let me know. The next question you have over here is we need to convert toluene to 3-nitrobenzoic acid. So for us to do that, this is from the chapter aldehydes, ketones, and carboxylic acids. So first of all, we're going to form alkyl benzene, or form aromatic carboxylic acid from alkyl benzene. So toluene undergoes this particular reaction to give us benzoic acid, and then the benzoic acid that is formed undergoes a simple substitution reaction or ring substitution reaction to give us metanitrobenzoic acid. So this is an example of a ring substitution reaction. And I also noticed that this was a question, or there was a question related to this in your textbooks. The next question, benzene to metanitro-acetophenone. So basically we want this product similar to this COCH3, because acetophenone. For us to get from benzene to this, first of all, we want benzene to get converted to nitrobenzene by reaction with HNO3 and H2SO4, and this will in turn this on reaction with AlCl3 and anhydrous AlCl3 is basically Friedel-Crafts acylation reaction, and we're just using that to form metanitroacetophenone. Okay. The next question is the optional one, or like it's this or this. Out of formic acid and acetic acid, which one will give the Hell-Wolodzelensky reaction or HVZ reaction? Give a suitable reaction in support of your answer and write the chemical reaction involved. So Hell-Wolodzelensky reaction involves the alpha hydrogen of the acid. So this gives us alpha halocarboxylic acids. Okay, so basically the primary requirement for a particular molecule to undergo HVZ reaction is the fact that it needs to have an alpha hydrogen in between so let me just write that. We have HCOOH, which is formic acid, and CH3COOH. Formic acid obviously does not have an alpha hydrogen, acetic acid does, and because of that, acetic acid will undergo Hell-Wolodzelensky reaction. And remember to learn all the named reactions. I do have a playlist which covers each and every one of them, so definitely check that out. And this obviously was from the chapter aldehydes, ketones, and carboxylic acids. The question B, alcohols are acidic, but they're weaker acids than water. Arrange various isomers of butanol in increasing order of acidic nature. Give the reason for the same. So first of all, what you need to do for this is you're going to have to write down the different I wonder if the different isomers of the butanol. So you have CH3, CH2, CH2, CH2OH. This is one. You also have CH3, CH2, CH3, and then this will be OH. And then you can also decrease one carbon atom. So CH3, CH3, OH, and then the last one is going to just have this OH over here. So you are left with CH3, CH, CH3, CH2, OH. So we're asked to order the acidity of the alcohols. So the acidic character is due to the polar nature. So when you have more electron releasing groups, what will happen is this will lead to a decrease in the difference in polarity between the oxygen and the hydrogen. So the most acidic is going to be primary, next is going to be secondary, tertiary is going to be the third. So because of that, you're going to have this as the most acidic, just a straight chain one. This is going to be more acidic than this, than this, than this, because this carbon is a tertiary carbon atom. This is secondary. No, this is secondary. This and this is primary. So the order is going to be 2-methylpropan 2-ol, 2-methylpropanol, butane 2-ol, and butane 1-ol. Okay, so this is based on the ability of or the number of alkyl groups that are attached to it. The next question is an organic compound A with Grignard reagent is used to obtain 2-methylbutane 2-ol. So basically, this is a reaction of production of alcohol from Grignard's reagent, and you have the reaction given as such in your textbooks for formation of a, notice that this is actually a tertiary alcohol, and for tertiary alcohols you need a ketone. So this is the reaction that's given in your solutions. Basically you have butanone reacting with methyl magnesium bromide to form the product that we require in the end. Okay, so with that we're done with question number 32, and this last one was based on the chapter alcohols, phenols, ethers. We specifically about preparation of alcohols. Last question of this question paper. Great, right? So question 33. An experiment was carried out in the laboratory to study the depression of freezing point. 1 molar aqueous solution of AlNO3 taken thrice and 1 molar aqueous solution of glucose were taken. We need to identify 1 and 2 and give a valid answer. So this is based on the Van 't Hoff factor. So basically the ability of production of the ions for AlNO3 is higher than that of the glucose. Glucose is not an ionic molecule, so when it dissolves in water, it's not going to lead to the formation of ions. Okay, so because of that, the value of I for glucose is going to be 1. For the AlNO3 is going to be 3 because of the basically you have the value of the value of I is 3. So because of more number of the or the higher value of the Van 't Hoff factor, there is going to be a higher depression in a freezing point. This is also because, notice, when you have the Van 't Hoff equation, you have delta TF is equal to KFM. So basically delta TF is, if you have this, it's directly proportional to the value of I. So when you have a higher value of I, this in turn means that the depression of freezing point is much higher, or the temperature itself is lower. So solution 2 is going to be the AlNO3 taken thrice, and solution 1 is going to be the glucose. And again, if you think about it, glucose is not going to form ions. So you could also just say that because of the inability of glucose to form ions, it's the value of I for glucose is going to be equal to 1 because it just dissolves, right? So obviously this is ionic, so it is going to form more of that, and because of this difference, AlNO3 is going to be solution 2 and solution 1 is going to be the glucose. Now the ones for visually challenged learners, which of the two solutions? So they've just given you the same question. All they've done is not given you the graph. They've just asked which of them will show a greater depression in freezing point, and all you have to do is mention the exact same reason for this question as well. Okay, just that the Van 't Hoff factor is different, right? Question B. The osmotic pressure of a solution of cane sugar was found to be 2.46 atmosphere at 300 Kelvin. If the solution was diluted 5 times, calculate the osmotic pressure at the same temperature. Now the osmotic pressure is given over here. So you have pi equals to CRT or N by V into R into T. First of all, you know that the temperature and the value of R, both of these are going to be constant. And because the volume is also staying the same, the value of the volume is changing, but there is no addition of the solute to the solution. So because of that, the value of N2 is also going to be constant. So basically you're just using pi 1 by pi 2 equals to N by V1 by N by V2. N and N can get cancelled, and V is equal by 5V because it is 5 times the volume. Now notice these people, they've used 2.64 and not 2.46. So the question given to you is related to 2.46. So the final answer is going to be pi 2, that is the final osmotic pressure, is going to be equal to 0.492 atmosphere. This is the final answer if you're using the value of 2.46 atmosphere. They've flipped and they've used 2.64. Okay, now how can osmotic pressure of a given cane sugar solution be decreased without changing its volume? So essentially what we're wanting to do is we want to change the osmotic pressure, but we don't want to change the volume. So the only other thing that you can potentially, if volume is going to stay constant, then obviously the value of N, that is number of moles, is also going to be constant. So the only thing you can do is change the temperature. So the osmotic pressure is directly proportional to temperature, so it can be decreased when you decrease the temperature. Okay, the next question. While giving intravenous injection to patients, the doctors take utmost care of concentration of the solution used. Why is it necessary to check the concentration of the solution? So this is again related to the concept of osmotic pressure, and this particular example is actually given in your textbooks. So basically we don't want the concentration to be that different than that of the blood cells. So this is because of, if it is more concentrated, it'll lead to shrinking. If it's more dilute, it'll lead to it'll start flowing out. And then because of that, or when its concentration is less, the concentration will lead to swelling. So all of these are not really good things, and all of this is also explained right here. Okay, and the next question. Okay, this honestly, it took me so long to solve this one. So a solution of phenol was obtained by dissolving 2 into 10 to the power minus 2 kilograms of phenol in 1 kilogram of benzene. Experimentally, it was found to be 73% associated. Calculate the depression and freezing point that is recorded. So basically, this is sort of related to the last example question given in your textbook. Okay, this is the closest I could find. Basically, what we need to do is we need to first figure out the value of value of I. For us to find out the value of I, we are going to use the relationship between alpha and I. Okay, so alpha is equal to 1 minus I divided by n minus, or 1 minus n. Okay, so this particular equation, when I tried to figure out this equation on my own, I actually got alpha alpha is equal to I minus 1 divided by n minus 1. So essentially all you're going to do is try and calculate the value of I using 0.73. You know that 0.5 minus 1 is going to give us minus 0.5. This is somewhat related to what you learned in the chapter equilibrium. I know that's last year's stuff, but basically we're just using the final initial and the final concentration. We're comparing those two, and we're able to get to an equation where we're relating the value of alpha to the Van 't Hoff factor. And so we're calculating the value of I. Okay, and then we just are using this equation, which is also given in your textbook right here. No, Over here, all you have to do is then just substitute all the given values in this equation, and the value for Kf for benzene is 5.12 kilograms per mole. I think it would be a good idea to just have a basic idea of the values of these, because this has not been given in this question over here. So all we're doing is substituting it and then figuring out the value of delta TF. With that, we're done with the sample question paper 2024-2025. Definitely let me know if you have any questions, if you found this helpful, and if you have a suggestion for a sample question paper or a previous year's paper, definitely let me know about that as well. Okay, bye.